Okay, just now we were talking about this group work. So the group work one, suppose that f is the function that computes how many feet are in m miles. So 1 mile gives us 5,280 feet. So we're multiplying 5,280 times m. If we have three miles, because f of 3, we would have 5,280 times 3, which is equal to 15,840. Okay. And so let's do this interpret part. Interpret, don't forget about the interpret. That's what everyone forgets about. What's the interpretation? "40 feet in 3 miles." And that makes sense because when you go to a smaller unit of measure, you're going to have more of them. Okay, let's look at example 8. What does example 8 say to do? State the domain and range of the functions using interval notation. Interval notation we learned back in Math 60, so it's been a while. So the domain is going to be the x values. And so I'm going to put the word domain all along the x-axis. The range is the y values. Okay? So domain, where does it start and where does it stop? What's the very first number on your domain? It's going to be right here, -2, right? Starts at -2. Is that number included? Yes. It goes on for, the arrow says, I'm going to go on for infinity. Yes. What about the range? So the range is up and down. Okay. What's the smallest? We always want to go from smallest to largest. So this arrow right here implies that that line, this curve or line or whatever, can come down, 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 down. So the range, it starts at, we always want to go small to large. It's going to go starting at -infinity because of that arrow. It's going to go up, 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 up. It's going to stop where? 3. Y is 3. And that number is included. So remember, the range is always going to be the y values. We want to go small to large. Okay? Let's look here for the domain. The domain goes all across. Domain is all x values. So if I put in x equals 2, I get a number, right? If I put in x equals 3, I get a number. If I put in x equals 4, I get a number. So these arrows say, hey, I'm going to keep going up and expanding. So what do you think the domain is of this function? Domain is -infinity to +infinity. Because those arrows keep going up wider, that means you're going to be plugging in more and more and more and more and more x values, correct? Now the range is our y. So range is all along here. What's the smallest y value? -2. Is that number included here? And then this is going up to what? Where does it stop? -2 to infinity. Okay? If it's included, meaning if it's not included, it would have an open circle. Remember that from Math 60, the open circle? Yes. So because this number is a filled-in circle, it means the number is included in the function. If it had started, I wish one of these examples, let's actually change this a little bit. Okay, let's change this to an open circle here. Okay? And then that would change things. So if we have an open circle, that means the number is not included. Okay? So for here, the domain goes across. Domain, where does it start? It starts at, yeah, anyone? -3. And why am I putting that bracket around -3? It's included. Where does it stop? Yeah, 6, right? And I'm going, now the notes online, the completed notes are going to have a bracket around that 6. Why I'm putting that open circle right now is just for the example of when we would use the parenthesis instead of the bracket, okay? Because, yes, like infinity. Why don't we put a bracket around infinity? Yeah, you can never get there, so you can't include something that you can't ever get to. It's more of a concept than a place, right? The range is going to be up and down. So we're going to start with our small value. So we're going to go, here's range. Okay. So now start from the smallest number. What's the smallest number on your range? -2 from here. So, and because I made that an open circle, it's going to be a parentheses. You see that? Up to, where does it stop? I think that's +4, right? And what am I going to put around the 4? A bracket. Okay. All right. So that pretty much concludes our group work. Why don't we just do that? Sorry, that concludes our lesson. Let's just do the group work really fast together, actually, because I think that sometimes these can be confusing. But we'll do it together. So find f of 1. F of 1. So you have this scatter plot over here. This is f of x. Find f of 1. How would I do that? Look for the x value that is 1. Go down to the point. Here's the point 1, -5. So what is f of 1? Everybody says -5. What is the value of f at 0? F at 0 is f of 0. Same thing. F of 0. F of 0, can anyone tell me? It's close. Yes, it's 5. 0, 5 is a y-intercept. Anytime you have x is 0, you're going to be on the y-axis. What is the function value at -6? F of -6 is, -6 is here. X is -6. Oh, there is no value. It's undefined. Undefined because there's no point on that line. There's no y coordinate. You see what I'm saying? Okay, solve f of x equals -5. So here we have y equals -5. So what is the x value that gives us y equals negative? You see how this is y here? Yep, it's 1. Okay, I know my curly braces, they could use some practice. All right, solve f of x equals 3. So that's where y equals 3. If I draw this line is y equals 3. The reason why I do that is because, remember, I could have multiple x values. X can repeat, the y cannot, right? Or I mean, I could have x could not repeat. No, that's not what I meant. I could have 2 different x values going out with the same y value. That's what I meant to say. So what are my solutions? Yes, 4 and 5. I can have 2 different x values that give me the same y value is what I meant. Y can repeat, x can't. List the domain and range of f of x, or f. Okay, the domain is going to be all the x values. So what are all the x values? -4, -3. I'm just going over, right, on my x, because here's domain is all the x values that I'm using. So you see these ordered pairs are where I'm getting my domain. Is -2 in the domain? -1, 0, 1, 3, good. 4 and 5, and 6. So the reason why I'm able to list the domain in set notation is because these points are not connected. When you connect a point, you have an infinite number of points. So actually, notice back up here, I could not list every single number in the domain. Well, especially because Because if it's an interval, it's actually, even if it stops at -2, I can't list every single number because I would have decimals, I'd have fractions. Whereas here, these are just individual points. Yes, you had a question. D and E, yes. Right. So for the solve for these, we're looking for the x value that corresponds to that y value. So as for example, for E, these ordered pair right here are 4, 3 and 5, 3, right? If I were to list all the ordered pairs, since both x values correspond to that y value, the solutions are 4 and 5. Because those are we're looking for, these are x values. Okay, who can tell me, what's that? For D, same thing. So we're looking for the x value that corresponds with the y value, -5. So if I go to y is -5 down here, y is -5 here, the x value is 1. Who can tell me what the range is? So start from the smallest, go up to the largest. So we're going to go range here. Okay. -5, good. Going up, -4. It's like going up an elevator. Okay, we're stopping at the -2 floor. We're going to stop at the -1 floor because this is -1 here. Are we stopping at floor 0? Am I going to make a stop at 1, 2, 3? 2 people get off the elevator at 3. And then we're going to stop at the 5th floor, and that's it, because notice that we only have a certain number of ordered pairs there. Okay? All right.